Hello everybody, this is the notes for calculus class, section 2.2. I'm actually going to do this in two parts. First part is going to be talking about some quadratic, some parabola characteristics, and the second video I wanted to have separate just because it's something that I want you to be able to access at any other time. So it's about transformations of functions. We're going to apply it to all kinds of different functions, but it's a different idea, so a different idea compared to the quadratics and the parabolas, but just I want it to be there for you to access later on if you need it. So, in this first part, talking about quadratics, okay? Most common look to a quadratic function is this ax squared plus bx plus c. Those numbers, a, b, and c, they do have some meanings as far as the look of the graph and what the function does. So the first thing is this a value, okay, the coefficient of x squared. If it is positive, parabola is going to open upwards. If that a value is a negative number, so you got a negative x squared, then that parabola is going to be opening downwards. It doesn't matter what the b and c value are. The b value, it does things, but it doesn't do anything directly. You know, if you change the b value from 1 to 2, there's no direct look at, oh, it did this to the graph. I mean, it changes the graph, but there's nothing direct. The value of c does. It's basically just a shift. You're moving that graph up or down. Moves it up if the value of c is positive, moves it down if the value is negative. So that's the most common look to the quadratic function that we deal with. This other one right here, it's called the vertex form. A times x minus h quantity squared plus k. A is the same thing as what we talked about over here. That's the same number. The value of h and k, it's kind of convenient in this form because it tells you the vertex, okay? And it's x minus h. Whatever that number is you're subtracting from x, that's going to be the x value of the vertex. That number that you're adding after the quantity squared, that is the y value of the vertex. So it's kind of nice to have an equation in that form. You get a lot of information about the graph just by looking at the numbers, looking at the equation. If you wanted to, and I'm not going to ask you to do this, you know, at least not now, that may come into play later on in the year. If you need to convert from the normal standard form, the ax squared plus bx plus c, into that vertex form, you do a process, excuse me, process called completing the square. And there's a few steps involved in that. It's not a big deal. It's kind of annoying sometimes, but I'm not going to ask you to do that right now. So, vertex form, nice, because it tells you the vertex. But the standard form, the ax squared plus bx plus c, you can still find the vertex from that by doing this stuff here. To get the x value of the vertex, it is a very simple equation. You do negative b over 2a. That gives you the x value of the vertex. To get the y value of the vertex, well, plug in that x value into the function. That will give you the y value. So you can still find the vertex no matter what form it is. It's just a little bit more work in the form that we're used to seeing. All right, so just for this example, what's the coordinates of the vertex for this parabola? So our a value is 2, our b value is a negative 11, c is a negative 6. But the x value of the vertex is negative b. So it's the opposite of the b value. So we're going to have 11 over 2 times the a value, which is 2. So we got 11 fourths. There's the x value of our vertex. To get the y value, we just got to plug this thing into the function. We're going to do f of 11 fourths. So we got 2 times 11 fourths squared minus 11 times 11 fourths minus 6. That gives us 2 times a 121 over 16 minus a 121 over 4. And then a minus 6. So instead of multiplying the numerator by 2, I'm going to cancel out a factor of that 16. So I'm looking at a 121 over 8 minus this 121 over 4. That is really 242 over 8, getting common denominators. This 6 If we put it as over 8, that will be 48 over 8. And so now, negative 121, just subtracting the numerators, 121 minus 242 is a negative 121, minus another 48 is a negative 169 over 8. There is our y value. Hooray. And that's how you find it. Okay? That's how that equation works. This was just the first part. The second video is going to be about transformations. Please watch that.